Container with most water, you're given an integer array height of length n. There are n vertical lines drawn such that two endpoints of the ith line or I, 0 and I, height phi. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. You may not slant the container. So over here we have a container over here, and they've given the levels the container stand over here in the graph, and water is filled. Okay. So over here in this, you can see this is the height of your container. So if these two form a container, they have a height. So this container is one height, and over here you have 8 over here. So I'll show you the diagram I've written over here. So in this you can see the height of this is 1, 8, 6, 2, 5, 4, 8, 3, and 7 over here, the loss. And these are the indexes. This is the x position. Okay, these represent the indexes, and the values or the height of the vertical lines over here. So we'll pick two lines and they would form the container. Okay, so we pick any two lines and they form the containers for us to hold the water. We're going to find the maximum water that that container can hold. For example, over here, a container means simply two lines. Remember that. Okay. Find two lines. You can see over here, you have to find two lines that together with the x-axis will form a container such that the container contains the most water. So here we'll find two lines that will have the most amount of water, including the x-axis. That means you cannot ignore the width. Okay, you must include both the width and the height of the container. So you can mostly think of finding the area. The area is something that you can find out. So you can also include with the x-axis to form your container. Okay, if you're going to find two lines, these two lines will represent your height and the x-axis will represent your width. Okay, so you can see over here the explanation. The above vertical lines are represented by an array. In this case, the max area of the water, the blue section the container can contain, is 49 over here. So I'll show you in the diagram how it is. So over here we have a diagram, and you can see that this part, this 8 and this 7 over here, is actually forming this line, the red color line, and this red color line. The both together is forming the maximum area. The area they're forming is 7 into 7, that is 49. Now I'm going to show you guys why here we got 7. It's that simple. So the first one is the width over here. The width is actually the x-axis. So over here it's going to be 7 because 1 let me show you. It's going to be 7 over here because 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and so on. Okay, so the width is going to be 7 and the height is going to be 7. Because for here, let's take a container like this. Okay, so let's say that this is the height of the container. This is one height and this is another height. Now you can see that the water can actually fill only till the minimum height line. Like if it does go till here, let's say it goes till here, it's going to overflow, right? So if you take a half broken container, let's take this container. Okay, the water levels can go only till the minimum height, the minimum bare minimum that it can hold, because it's half broken, and if it goes beyond this, it's going to spill out. So the container's actual holding capabilities will be actually the minimum height it has. So over here you have the height and the width over here, right? So how do you calculate the height? Now we got a pretty good idea. So basically we'll just take the minimum of the two lines that we're going to consider. So we'll take the minimum of both to actually find the height, okay? So the approach we're going to use over here is going to be a two-pointer approach, where we place 2 pointers in the sides, and we'll just compare, and we'll start moving the pointers to actually get the maximum area over here. So we have our left pointer over here, and then the right pointer at the last, pointing towards the last. Now this is why it's going to help us define the height as well as the width. So if you want to find the width of this, then we have to simply minus the indexes of right minus left. So when we do, we get the width. So over here, the first step, the width is going to be 7 minus 1. That is going to be 8 minus 1, because we see the indexes over here. So 8 minus 0, that is going to give us 8. So 8 is going to be the width over here. So I already told you how to calculate width over here. So this is 1, 2, 3, 4, 5, 6, 7, and 8. So we have, each container has a width of 1, so that so from here to here to here. So how much water it can actually hold? So over here we have 1, and this one is 8. It's enormous. It's 8, and here it's 1. So when we form a container using them, we pretty much get to only this. The water levels are going to be only this. So this is the amount of water we will actually be getting. So over here, how to find the height. So the height this container can hold is the minimum of height between the first one and the 1 and the 7. This is actually 7. So 1 and 7. So 1 and 7, it can hold up to 1, a height of 1. So 8 into 1, the area is going to be 8. Okay. Now for now, this is going to be the maximum area so far, because still it is our first value. So let's try to move further and let's explore other possibilities as well. In the way that we're going to move the pointers are actually like, if your left value is smaller, then we try to move the left front. If your right is smaller, then we move right backward. So over here, we have updated our pointers. So the left is pointing towards the first index, and the right is still at the last index. So let's move further. So right minus left. To find the width, we're going to do with the indexes. So 8 minus 1 is going to be 7 over here. And the width over here, we're going to calculate, so this is the width. The height is going to be the minimum of both of them. So over here, the container water can actually hold this much, right? It can hold this much, up till 7. So the height is going to be 7. So far, this 7 into 7 is going to be our maximum. So let's store it as the maximum. Now, we need to further explore other possibilities as well. Let's go. In this case, left and right, which is smaller. This right value is smaller, so we cut off the right and we put right over here. Let's make it on the colors. It's kind of, so right pointer points towards here, and the left stays the same. So 8 and 3. So right minus left is going to help us find the width. So our right value is 7 and our left value is 1. So 7 minus 1 is 6. So if you keep noticing, as we move further, our width is also decreasing. Let's talk about the height. The height over here would be only 3. As already mentioned, 8 is over here, and over here 3 is the container. You can see how small 3 is, and if I do overloading, then it will spill out. The 3 is the height the container can form. So 6 into 3 is 24. Now this 24 is not maximum as it's lesser than 49. Let's move our pointers. How do we move pointers? We compare the values of the left and the right height, and we check which one is smaller. 3 is smaller, so right is going to move up over here. So right is over here, 8 and 8. Now let's talk about the width. Over here, the width is going to be subtracting 6 minus 1, so the width is going to be 5. So O minus L will give you the width, so it's going to be 5. And the height is the minimum. So 8 and 8, 8 will be the minimum. Now when I do a FISO 40, now 40 is not greater than 49, so still 49 is actually the maximum area still we have found. Now 40 is not a maximum area, so we try to move. You can either move left or right. You can either move any one of them. So we're going to move because both of them are same values. So even if you move the right, it's alright. If you move the left, it's fine. Nothing matters. So this time I'm gonna move the left. So let's try moving the left. And the right stays the same. And I mentioned already, you can move any one of them as long as both of them are same. So left and the right. Now left and right has 6 and 8, and the width of course is going to change. So left is now 2 and the right is now 6. So right minus left is going to be 4. The height is going to be the minimum. So now the minimum value is the left minimum. So over here it's going to be 6. 6 4s are 24. So still the maximum area is going to be 49. So now you can move your pointer. So over here 6 is the minimum. So I'm moving my pointer over here, which is left. So 3 minus 6, 6 minus 3 is going to give me 3 is going to be my width. My height is going to be the minimum of both. So over here 2 is the minimum. So 3 2s are 6. 6 is the area I can hold. This 2 is the height over here. And we got 8. So that is the water you can see over here. You can only hold till the minimum. So now the left pointer moves over here because this is the minimum still and 8 is the maximum. Now 8 and 5, as you know, let me do it here. So 6 minus 4, the width is going to be 2. The width is going to be 2. The height is going to be the minimum, so it's going to be 5 over here. So 5 into 2, it's going to be 10. So it's going to be 10, and it's still not the maximum. So now left pointer moves forward, 4 and 8. So let's go 4 and 8. 4 and 8. 4 is the minimum. 4 into we'll find the width is going to be just 1 over here. So you can see the width is just going to be 1. 6 minus 5, it's going to be 1. So 4 into 4, 1 is 4. Okay. So now what happens over here? The left is smaller, so it comes forward. Now when left and right, both of them are pointing towards the same, it exits It exits out of the program and it returns the maximum area we have found so far, which is 49. Let's start writing the code. So first, left is 0, right is height length -1. So we will point towards the last index and hint maximum area. For now, let's have it 0. Now, we will not have any negative areas in this case, so there is nothing to worry about any negative numbers having the maximum area, so you can have it as 0. Now let's go for the while loop. So in the while loop, we'll have left and right pointers. So when left is not lesser than right, it actually comes out of the loop. That's why we have them. Now the next one we'll do is find the width. So the width is going to be right minus left. Okay, that's going to be our width. And now let's find out the height. The height is equal to mat.minimum. We need the minimum of the height of left and the height of right. Okay, right and left points towards the index. So that index, whichever value is there, we'll find the minimum. Next value, we're going to find the area. The area is nothing but width into height. Now we'll find the maximum area. Max. We'll go to the maximum area. The maximum area will be area or else the max area itself. After we're done, you need to remember we need to move the pointers. Now these pointers move under a condition. So the condition is very simple. If the height of my left is lower than my height of my right, so in our case we have considered if even if it's equal, we have moved the left pointer forward. Now you can also skip this part and give an else condition down, which will automatically handle if both of the left and the right are equal. It will try to move the right pointer, but in our case, which we saw in the diagram, we have done this case. So that's why I've given that. Now right minus minus, and then I'll return the maximum area. So after this, after a while loop, you can return the maximum area. Height already defined. Oh yeah, it's already there, so we can change the name of it to hatch, and over here to hatch. Now let's run. Alright,